Guests. This is episode number 444, being recorded on the 26th of October, 2022, with special guest Mark Eisenberg. I'm Sujit, and on Teams with me, we have Russell, Evan, Kale, and of course, our special guest, Mark, who we've had on the show before. So I think everyone, or most of our listeners, know who Mark is. And we're here to talk about a special topic that came up during the Ignite week last week about Azure renovations. Mark offered to kind of dive into those announcements that Mark Russinovich made, and we're going to discuss that in just a minute. But before that, let's get into some of the news. I see, Kale, you had some stuff out there you want to talk about?
Yeah, sure. I got two here today, which are kind of random, but important things. We talked a little bit about in the past on the podcast about some of the AI and computer vision and different features that we have in Azure to support those kind of workloads. There's a new image analysis version 4.0 with a new API for OCR for optical character recognition. So essentially, this is be able to support. This is kind of crazy, but it can actually support 164 different languages now, including like Arabic and Hindi and all types of different languages from just pictures. These are basically, it's a kind of an interesting blog post about how these are actually tested at scale with our own products. So if you look into the kind of M365 line of products like PowerPoint and Word and Outlook and things like this, a lot of the backend that's being used there is using some of these features as well. So it kind of details and walks through what's going on there. This is primarily around the computer vision, as I mentioned before, the OCR piece. And it also mentions our responsible AI and how we're kind of adhering to the policies we have there for that, which is pretty cool. The second one kind of also goes along with AI, but in machine learning. And this one's around the Azure, GPT-3 stuff that we've been working on, along with a partnership with NVIDIA. They have some new framework called Megatron, Nemo, which is in beta right now. And basically, it's a way to, and this benchmark was basically run against 175 virtual machines running in Azure. And it basically shows the training time and how the combination of this technology along with from NVIDIA, along with our hardware in Azure, would provide like linear scale for training times to basically show it's learning very fast, right? And can drop off, pretty much straight linearly. You can look at the graph there, which is pretty cool from a compute standpoint, along with the need for like this kind of stuff as AI becomes more prevalent. The ability to train these things in a rapid way. This is pretty awesome, to see the partnership between NVIDIA and Microsoft. So all the results and everything are published up there. You can take a look at all the details. That's it.
Awesome. Thanks, Kale. I think Evan and Russell, you guys had something as
I
well?
I don't have anything. I don't think this week. Oh, the DevOps employments, but I think we're going to hold that one until we get somebody on the show. But I mean, in short, these are if you remember, like I think it was GitHub Workspaces, I think it was called, where you could sort of access a pre-configured environment. This is taking that to the next level, where it's got all your dependencies. It's got all your all the other build environment stuff that you need. It's really that on steroids. So I think it really speaks to the complexity of maintaining a dev environment. As anybody who's been a dev ever is, it's non-trivial. Yeah, Kale just said on the side, it's code spaces. This is taking that to the next level. So I think we're definitely going to get them on the show. I've got it on my list to do this week.
From me, I just saw I saw app service environments being retired, version 1 and 2, and I always look at these things and think, oh god, I've got to do something about this because there's loads of people on that. Then I just realised it's only version 1 and 2, which were the ones which were built on the old cloud services model, hence why they're being retired together. And it's not actually happening until 31st of August 2024. So you've got a while to migrate onto V3 for that. But anyway, that was the only one that caught my eye. And like all these announcements, they're so far away in the future, you've got plenty of time to do something about it. And
but then again, Russell, 2024 isn't as far away as it used to be. It sounds like it's really far out, but yeah.
Well, you listen to what Cal was saying about, how fast AI is moving, and our ability to do stuff that much faster now, and some of the stuff from Ignite that we're going to talk about later on today, I think, just incredible, isn't it? The pace of change and the pace of improvement.
It is.
Yeah, but so it's funny because being on the support side, and I just went through. I didn't have to deal with it. Fortunately, the CSAMs did, but we announced the deprecation of basic TLS, I think, basic authentication, and 3 years. And then we had people coming up 2 weeks before the deadline when we were going to turn it off, going, "Why didn't you tell us?"
and we pushed it out a couple of times too, Mark.
Yeah,
right? Remember,
and we pushed
right?
it out.
So,
we allowed them to apply for a 3-month extension. We pushed again to
Yeah.
the December 31st, but there's a whole finger point. This means you at this point.
Yeah.
And,
Well, now they've got no excuse now because we've announced it on the Azure podcast. So everyone.
there you go. That's right. If you don't know now, then. But but the whole
go ahead, Mark.
one of the things that caught my eye in the DevOps handbook when I read it not that long ago was that 20% of each sprint is supposed to be for tech debt retirement. And I'm starting to press this idea with the customers because they can kick the can on tech debt indefinitely.
Yep.
And then this is the exact kind of thing, we give them almost 2 years, and they're going to put it on their tech debt list, and they won't deal with it until June or July of 2024. So
that's a good shout.
That's humanity. What can we do?
Yep.
Yeah, no, that's a good strategy, Mark. Before we kind of get started with Mark, I also want to point out that this week is KubeCon is happening out somewhere.
Isn't Kendall out at it this week?
Yep. Kendall is out there. I think she did a session yesterday at KubeCon, and we'll put a link to that in the show notes. I'm wearing my KubeCon jersey from a few years ago in support of that. There's a few announcements there that we should keep a note of maybe in the next episode. For now, let's turn the mic over to Mark, who I think our listeners know from before, but Mark, I believe you may have changed roles recently, and maybe another intro is in order here. So go ahead.
So I changed titles and parts of the organization. The role is the same. You know how it is around. So yes, I am now formally a cloud solution architect, which was cool because Sujit's been bugging me for like 3 or 4 years that I should be a CSA. And I was like, I don't want to be that technical. So then they wind up giving me the title anyway. So now I'm a CSA. And yeah, I've been with Azure. For those who don't know, I was one of the first 4 Azure sellers in the country. There were only 17 of us that year. That was the fall of 2009 when we launched Azure. So I've been at this for a long time. I will say that with a lot of what I'm seeing customer facing right now, that the things that we knew needed to be done back then, those of us who were in the cloud know, the customers are finally catching up with. Going into the cloud to save money alone is, and not changing up your architecture, not modernizing your architecture is really a kind of a non-starter. So costs are getting out of control. We've got one wave now of we're getting people onto reserved instances to try to cut some costs, but that's a one-stop move. There's only so far we can cut those prices. And so now the modernization work, I think, is going to start. And then there's the fun stuff of just getting the application tier rebuilt. And that's why, how's this for a segue? That's why this session that Mark Russinovich did on Azure Innovation really caught my eye, because there is a disconnect between what we're doing with Azure, the innovation we're doing with Azure, and how we talk to enterprise customers about it. We tend to talk about Azure with customers in their language, which is, sad to say, mostly yesterday's language. And if you're in support, which I guess most of us have touched support at one time or another, you see the really negative outcomes from doing things in Azure in a traditional way. It's just not good. And so the things that he was talking about, and Sujit, did you get a chance to watch the session?
Yes, indeed.
Yeah. So he started with, some data center architecture stuff, which really was focused on cooling and power efficiency. And we've got some really impressive numbers going on there. And seeing him sticking his hand into a vat of 100-degree coolant that evaporated right off his hands was really, seeing server boards in the just buried, submerged in liquid is an interesting experience. Anybody who's fallen in water with an iPhone in their pocket knows that's quite a feat to make that work.
No.
And he also mentioned, I didn't realize this with what was it called? Neptune, the submerged
Project Natick.
Natick,
We had them
right?
on this. Yeah, we had them on the show. A while
Apparently,
ago.
they were testing pure nitrogen environments
Yes.
there for cooling.
Yes.
So seeing how we've taken that experiment and are starting to operationalize it in real data centers is pretty cool. The confidential computing stuff, because I've always wondered, it's why we encrypt at rest, we encrypt on the wire, but once it gets into the CPU, it's, if you get code in there that hijacks it, there's nothing to stop, getting access to that. Yes.
I actually thought the company you're calling on the confidential computing. By the way, shout out to you, Mark, because I think you're on your 4th time with us, which puts you at the at the top end. There's a couple folks that are tied with you, but we're just putting it out there. You got to find a 5th, and you're good.
I'm pretty sure
5th.
this
I'm
is
sorry,
the
my
5th.
bad. My bad. Maybe you are there. But again, really appreciate you coming on over time. The confidential computing piece, the piece that I didn't think about until Mark mentioned it during the Ignite session, was the thinking this is really going to be the norm, right? Confidential computing is not. It's not niche, it's not specialty, it's not something that, for a subclass of customers. This is really, that sort of was my thinking personally, to the point where we think this is ultimately just going to be the way everything is done.
Yes.
I like the way that he paraphrased that. Like, back in the day, TLS was something special.
Yeah.
And now everyone uses TLS. Like, nobody does not use TLS. And it's going to be the same for confidential compute in the future. Everything will be confidential compute. There's no reason why you wouldn't use it.
But it's more of the hard sell, right? For us, we need to be, there's this a phrase, if you guys know Jim Priestley, he taught me, strong opinions loosely held.
Yeah.
Right. And so this is and that's what struck me about this session, is that we get beat on a lot all the way to the product groups about how we're not doing what the customers need us to do. But we are doing really, really cool, innovative things. We just, from the beginning of Azure, like I said, I was there from the beginning. And the first time, I probably have told this before, the first time I saw DPE present, that was our evangelism team at the time, present about Azure, was 20 minutes in front of the CIO for the account I was on. And he talked for 20 minutes, and in my head, I went, so who cares? And and then it was like 8 or 9 months later, I got the opportunity to interview for this role, and I started reading Dave Chappell's white papers and all that kind of stuff, and I got it. And we're still struggling there with the greatness that is cloud computing, the paradigm shift that it can represent, and how do we talk to the customers about that when we're all wrapped up in how they want to do things. And like I said, pretty much the way they want to do things is yesterday's way. One of my favorite laugh lines these days is I would talk to customers about continuous delivery, CD, Jez Humble stuff. And I said, here's how it goes. I will ask, have you considered continuous delivery? And then I lean back and wait for the next 45 minutes as they tell me all the reasons they can't do continuous delivery. But they all say they're doing DevOps. Continuous delivery and DevOps are really joined at the hip, from the automation and all that kind of stuff. So these are the conversations that, and I'm hoping in my new role, actually, we get to drive those conversations. And to your point, Evan, about the confidential computing and casual, the throw off, that this is how things are going to be done in the future. Not if everybody just keeps doing things the way they're doing them. So yeah, we've built the cool stuff. Now the hard part starts, is changing people's minds.
I think that the thing that's neat when you talk about that evolution, because we talked about this before, Mark. I was right there with you in the early days, and we were like, PaaS is the thing, and now everybody's coming back around to PaaS. if we do it right, if we, confidential computing and TLS, I think are really good analogies because 99.99% of the time, the application developer or workload developer doesn't know or care what they're using from a connectivity perspective. It's just a
Correct.
REST call, right?
Right.
We call it an HTTP call, but under the covers that, it may or may not be HTTP, it may be HTTPS. Right. I think confidential computing fits really well in that, which is if we do the innovation right on the Microsoft side, customers just check a box somewhere that says, yeah, use confidential computing, and nothing breaks, nothing changes
Right.
for their workload. Now, I don't think we're there yet today. But I think that's the vision. And I think when you think about the innovation, that's really where the value is making sure the innovation works well with what customers want to do. Because if, when we were joking about the TLS stuff, if the effort they have to exert to do that change is sufficiently high, right? If you can't exceed the activation energy, it's not going to happen, right? So we have to reduce the effort to get there, while still getting them to think about it.
But they still, right. And I believe his demo there was combination of configuration and code. There was a code in. So
Yeah, I
that's
can't
where it's
remember.
different than TLS. You're right with TLS. We just flipped a switch. Dapper, makes all that invisible, right? That kind of, it's all invisible. The service meshes make it invisible. So that one's pretty easy from an application tier perspective. But this one, the developers are going to have to change how they do it. At an even broader level, and I've talked to a lot of people about this, and nobody's been able to say this isn't wrong. We've spent the last 30 years or so making the pipes secure, trying to make sure that nobody gets onto a wire to see things that they shouldn't see. The reality, number one, I've not been able to confirm any known successful man-in-the-middle attack. I can't find it. Two, if you do proper API security, do a service-oriented architecture, and do authentication and authorization checks, and we've made, to your point, Evan, with Azure AD and the like, we've made that pretty easy to get that far. It's not really a problem, but the developers still need to do it. And I think with Dapper, we even pulled a bunch of it over into the Dapper sidecar to take care of all of that. But again, the developers need to come along. The architects need to come along. I put them both together because I think the architects need to mandate it and the developers need to implement it. So that's why the confidential computing thing, I think, falls into a higher tier and would require more effort on our part to get the people to actually change how they do things.
And I believe,
yeah.
So I was going to say, I believe right now with the way I think it's the SGX chipset that we use in Azure for confidential compute, there is a specific SDK that you have to embed in your code to kind of wall off, the confidential part of your code versus the non-confidential part. And that's that. You're right. So that's the kind of barrier to entry right now. Developers have to understand that SDK, make the changes, and test it, and all that stuff. But where they're going very soon now is they're going to have these thing called confidential containers or confidential Kubernetes and confidential SQL, in which case the developers don't have to do anything, right? Their same containers just all will be encapsulated in this enclave, in this secure enclave. And what you were talking about earlier, some of the tooling and whatnot is more around the attestation, right? How does somebody from outside know that this call that I'm making is to a secure enclave, and that secure enclave is the one that I am expecting, right? Like it's like, Mark's secure enclave versus Evan's secure enclave. I want to call
Mine's
the right
always
secure
better.
enclave,
Mine's
right?
always better.
Yeah, probably. You're more hands-on.
Yeah, just to follow on with that, Sajid, I've been working, with SGX for a long time, as part of the blockchain work. I think Sati even mentioned at Ignite, the managed CCF product, which is hinges on SGX and confidential compute. So I think the challenge there, like that's been, and maybe it's becoming reality now, like with the container piece with Kubernetes and things like that, is like we can provide this like minimum bar, like you can get into like confidential compute with it. You're in there then, but like to really take advantage of it, the developers need to do something, right? They need to like provide these like attestations back and things like that. And maybe that bar will get lowered again as innovation happens and things happen in the future, but there's still like you can get in and you can be like, I think we want the mass to get in there and start using that because they do get some benefit from that. But if you really want to like push it and do even more, then it takes developer effort, you know, a bit.
Right. Yeah. Did you guys all know who Donald Knuth is? Remember him?
Mm-mm.
So he wrote the 4-volume algorithm set back in the 60s or 70s. He was like it was before the Gang of Four, there was Knuth. And he had a phrase, I think, in one of the books, and it says software is hard. So we can get to what a friend of mine used to call irreducible complexity, but at some point it's still complex and the developers got to get their stuff together and participate in this. So we can bring all the innovation in the world, you know, to the party, but if people do not change how they're doing things, and I used to have this talk track that CIOs will say, we want to be able to reuse our existing skills, but we want to be better, faster, and cheaper. It's like, no. It's like, that is logically inconsistent. So, anyway, so yeah. So, and that particular demo was particularly cool where he breaks the key, he breaks the hash. And you get the error message. I mean, that was a really nice demo. I'm not a big fan of demos normally, but that one was really sweet.
Yeah, it brought the point home about the whole attestation thing.
Right.
And
I think go ahead.
Go ahead. No, go ahead, Mark.
No, I was going to move on to the next topic. So.
Yeah, I was actually kind of going back to what you started with, which is you know, the density of the boards. You started talking about how, you know, these boards are kind of so tightly packed now.
Right.
And what I didn't realize is that, you know, we've been fiddling around with overclocking in our home PCs forever, and Mark himself does it, and now they're doing it on all the Azure
Right.
CPUs.
Yeah, that was kind of
They're
weird. Yeah.
overclocking all of them. So it looks like overclocking is the way to go. Now that they have the liquid cooling and whatnot in there, they can afford to kind of get those, I guess, those boards and CPUs a bit warmer than they used to. But you know, I particularly like the fact that they're using less energy, right? In this, like I think they call the PUE number or something,
Yes.
which represents the amount of energy going in versus, I guess, the amount of compute coming out, and that number is reducing
And
dramatically
ideal
now.
is 1, right? The target
Yeah.
is 1, or is it target 0?
It should
think
be
it's 1.
1. Yeah, it should be
It should
1.
be
What you
1.
get, what you
Power
put
in,
is
power
what you,
out.
yeah,
Right. Okay.
yeah.
Yeah, and they're, I think, almost like 1.02. I think is the lowest
Yeah.
theoretical
With the
number they
liquid
got with that.
cooling, we're
Yeah,
102.
with the
Yeah.
Matic thing. Yeah.
So,
I think
Russell?
1.82 was with the Nuntic experiment, wasn't it? The thing that surprised me with all that, and I think the thing that really linked it all together, was that fact that, you know, we're experimenting with liquid cooling because we can then do more density of where we're putting the boards of the compute and all the rest of it. But I didn't realize we were building 50 to 100 new data centers every year, and that plan is still going on. And when you think about that, and then the need for the, you know, the efficiency of that compute to get better, and that leads to then more sustainability gains, which obviously is important to the planet and our Microsoft goal of being net negative and all the rest of it. So it's all, again, they're all things that we're innovating and doing that aren't necessarily driven for a customer today demand, things that customers want and they know they're there, but it's not something that, you know, other companies maybe are focusing on quite so much. So I really like the fact those things are all linked together, and that way that whole innovation is giving us gains in sustainability.
Yeah, and there, I was reminded, I forgot there was another infrastructure topic, which was all the offload stuff.
Oh yeah,
The
System on a chip
FPGA.
stuff.
You know,
Yeah.
and the numbers, you know, and the doubling of the storage bandwidth and the network bandwidth. And you know, it's interesting. We are, I think we're still the largest software company in the world, and yet we're doing a lot of hardware work now. Very big in the hardware business. So, so that was very impressive. I'm waiting for the nirvana on the FPGA stuff is the fact that you can actually, at the application level, reconfigure the hardware to optimize the hardware for the application. And there's a lot of complexity in how you would actually make that work. But that to me is like, that's a very intriguing idea.
I thought they have SKUs in Azure that have FPGAs.
They do. That's the F series stuff.
Right.
Is
But I
all
don't know what it
all the
takes to
GPU
use
stuff.
it. Yeah, I would
So,
have
so
that. Yeah,
it's
go ahead.
actually funny, because they're doing this. So there's all the GPU based stuff, right? Has an FPGA
Mhm.
component, but if you're using accelerated networking, it's offloaded to the FPGA. That's how we handle that. The FPGA
Right.
handles the flow mappings and stuff. So you're actually using it
But
almost
are
all
we
the time.
doing
Is
it?
that
Who writes that? Who's
we
programming
do
the
that? So we
FPGAs?
we write that
Right.
code at the end of the day.
Yeah, I think
It's
Mark's talking about application code running on the FPGAs, right? Specifically, is that what you're
Or
referring to?
configuring the FPGAs for the, really customized offload. We're really good at the optimized side of it.
Oh, I see.
We see a bottleneck, we figure out how to use the FPGA, and then of course the pattern's been over the years of the semiconductor industry that you do it in an FPGA and then eventually you fold it into some other, you know, full custom chip. But the idea of at the application level, you can make it part of the architecture, custom hardware. That's a very intriguing idea to me.
And so,
And
so what Evan, I think what you were saying is that FPGAs are currently on the individual VMs, right? Or the actual
so
servers.
they're in the racks and associated with any individual physical host under the
Correct.
covers.
And I believe what Mark announced at Ignite is that now they have those FPGAs have been offloaded to a standalone device, okay, that sits in front of all the VMs. I think they're saying they built a system on a chip now
Yeah,
with
the sock.
Yeah.
Yep.
Marina Linux on it,
Yep.
and so the FPGAs are on that like offloaded device, which is obviously optimized. And so then that reduces the need to put the FPGAs in the actual host machines
Right.
because the
Mhm.
offload, the networking complexities have already been taken care of
Yep.
before they even get there. And therefore they're able to, I guess, even more tightly pack
But that
those
wasn't top of
VMs there.
rack, right? That was server by server.
I think it's still server by server with the sock stuff.
Okay.
Yeah,
Okay.
I'd have to think about the architecture stuff. I'm pretty sure it is.
I liked how he showed the system
Yeah.
on a chip with the fan and the
Yeah.
FPGA with the fins,
Yeah.
and then the
Yep.
actual adapters, plugged in the end of it. Yeah, it's an interesting piece of hardware.
And
I
what
was double E coming up, so I've got the background there.
what did you guys think about the Elastic SAN? That's the new, I guess, where it uses Azure Storage as a backing. I thought that was pretty interesting.
Yes, about time.
Yeah.
I mean, that's really been kind of, well, that was an intriguing hybrid thing for me because that was sort of the vision from the beginning that, the customers would change from traditional SAN technology to, sorry about that. Thanks. See if we
There
can
you go.
force it to refocus. Okay. But then we expected the customers would come off of the traditional SAN technology. But now that we've done so much migration work, we need to embrace the SANs because the lift and shift doesn't work very well without that. It's just a big lift. So to figure out how to do that within the construct of how our natural storage system worked was pretty impressive. And at that performance level was pretty amazing.
And
I
you're
think that
referring to the striping, right? The striping of the storage
Yeah,
accounts that
exactly.
they introduced for SANs. Yeah, that was pretty cool.
yeah.
Yeah,
I
that
think
was
this
in
goes back to
preview,
what,
right?
yeah, I think so. I think it's public preview now because we announced it on the blogs as well simultaneously. I think that this goes back to your previous comments, Mark, around there's this real delicate balance in terms of evolving what customers are doing versus meeting them where they are, right? And trying to walk that line is tough from a technical perspective as well as just from a business perspective. And so the Elastic SAN will be interesting to see where
The
it goes.
technical part, I think, is the easier part. It's the
You're probably
business,
right.
and I think I said this when we were doing the build recap. We use this phrase, meet the customers where they are. The customers are 10 paces behind us from a technology perspective. So that's not good for them, and it's not good for us. This is a partnership. Our customers, we convince them on the value of running their stuff in our data centers on our managed services. It kind of, I guess it's unstated that you kind of need to conform to how we do things. That's part of the give get. You give up some control, you get a lot of value. And that's not how we've been managing the customer base. So that's a story we need to get a lot better at telling, going
Agreed.
forward.
Agreed.
So, yeah, so
I think
yeah,
Russell,
you can
I
tell
think
because
Russell
I've been
was trying
doing
to
it a
get a
long
word in.
time. The whole meet the customers where they are thing, it doesn't work for us, and in the end, it doesn't work for them either. They wind up unhappy, and the problem I have with customers who wind up unhappy in Azure is they blame Azure. And that's also why this particular session excited me, because it kind of gave me a fresh injection of how good we are at this and how it's not being properly, really leveraged by the customers. And then you're right about the SAN. That really struck me as that was a way of meeting the customers where they are, kind of on our terms. And so that was a good thing. So the next thing he talked about was I believe, was the Azure Container Instances work that we're doing the warm capability there to spin them up faster. But what really struck me about that presentation, because the performance was cool and the demo was nice, but he said, we believe this is the future. This is the way things are going to be done. And I have not heard ACI mentioned in front of customers in a long time. And so we need to get on this. This is the model. The self-managed Kubernetes, it's not working. It's the
hard.
customers doing more of the same things on a different platform, but still doing it the same way. Reuse our existing skills. I've been involved in a couple of cases recently where we're trying to troubleshoot what's inside the container. The operations guys have no idea what's inside the container. And when you ask questions like, well, do we have logging to show X to see what's going on? No. And so this is what I call the big shift left, where all of these decisions, all these conversations need to shift to the beginning of the process, your application architecture, your data architecture, your DevOps, your observability. All of this stuff can be trivially built in while it's still on the whiteboard in the conference room. And I don't want to be sitting there in prod trying to help somebody. And this was a live cluster with a customer on it, trying to help them debug, and they don't have observability in it. And then what do? Start guessing? Not my favorite way of troubleshooting things. So that was the thing about the ACI thing that we believe this is the future. Well, if we believe that, then we need to evangelize that, and we need to start convincing people that's the way to go.
Yeah, I quite like that transition that you made from talking about elastic SANs, support SCSI interfaces and stuff like this, which, phrases I haven't heard in a long, long time. and then the phrase was, the future of infrastructure is containers. And I've not really heard of it expressed in that way. It's always been about, the future of app development is going to be containers. And that's how app developers can look at doing things. But actually looking at it from an infrastructure point of view makes much more sense. And then serverless container hosting with ACI, it just makes a lot more sense in terms of how you can deploy stuff, manage stuff, guarantee all that, the consistency across the container. So just brilliant. Yeah, I thought he did a really good job on that segue, and all that infrastructure stuff kind of just disappeared out of my head again, which was great.
Right. Yeah,
And-
exactly.
and,
And you're right
talked
about
about the
the app value from the containers, but then the ops guys have hijacked Kubernetes and are using it as basically a fine-grained virtualization layer.
Yeah.
Right? We haven't really leveraged the benefits of it, but we talk about it all the time at Build and Ignite and all that, but that's not what I'm seeing enterprise developers doing right now. So we got a lot of selling to do.
So how does
Sorry,
that
that's an evil
warm
word. I guess I
pooling
shouldn't have said
work? How does this warm pooling work? Like he explained about the warm pooling, right, with ACI. What was the
Yes.
concept? Is that the entire container group is kept alive? I didn't quite get the essence
You
of
can,
that.
yeah, you can basically, because there's a spin up time, and that was what the demo showed. If you do a cold start, it takes a while to bring the containers up. I don't know why, I don't know what the mechanism is there, but it takes a while. All right. If you have a highly elastic application, you don't want to have to wait on that. You don't want to take an hour to bring up your cluster of containers. So we're giving you the ability to pre-warm, I think we call them pre-warming, all right, so that they're loaded up and ready to go. I'll be curious to see how the price models, if you're not using it, you don't pay
That's
for
what
it.
I was
Otherwise,
wondering.
the economics breaks, right?
Yep.
But we're consuming capacity by keeping these things live. But if you remember in the earlier, I think he did where he updated the hypervisor demo earlier in the session, and we can do all of this stuff now in fractions of a second or just a few seconds. So I suspect we're using that kind of technology to warm these things up and then park them and then get them back in, so we don't necessarily give up all of the capacity. All of the software part is warmed up, and we're getting good at the hardware part happening quickly.
Well, remember too, on the hardware layer, this is the benefit of from a hyperscaler perspective, in that you may not need a container right now. You might need it in an hour, but somebody else needs one now. Right.
Yes.
So we can sort of peanut butter over the peaks and valleys of all the average customers to make that work out in the end. That, you
Right.
could never do that if you had your own, hypervisor or your own data center, because you just don't have enough breadth to cover that. So I'm sure that plays into it.
And I feel like the application developer also has to play a part in this container pre-warming thing, because
Yes.
the containers themselves have to start up, right? If you have like this awful system where it takes like you have to have big initialization routine and all that in every container, that's going to defeat the purpose, right? It's
Right.
still going to take a long time to start up, and so you have to come up with an architecture that does make those containers lightweight, quick to start up. I know Mark would love if I go into a microservices discussion, but
That's my
we have
thing
to
still. Don't get to
we
spend
have to
enough
keep
time on
these
it.
keep these things lightweight. But we got a few minutes left, and I wanted to jump onto kind of the last topic, which is of course quantum computing. So Mark, what was your takeaway from that?
Early days. I mean, it's because I'm also involved in the like the avatars and teams and the new headset. I got the new Quest headset here, and people want to be down on this kind of stuff that's out in the future. But just like with Elon Musk, if somebody doesn't try to build it and then start to drive it down the cost curve and the efficiency curve, then it never happens. And so, what impresses me is that we're putting the effort in. I think it's risky, because if I understand what he was saying is that there's a theoretical construct that we still need to make real. It needs to be, we need to manifest it physically. And until we do that, we are not going to be able to make quantum real. But we have sorted through all the different ways, and this is what we're putting our efforts into.
Yeah, and I sort of heard that they did demonstrate that it is possible. That topological qubit that they were talking about, they have
Oh,
demonstrated
right. They
that
got the one.
they
Yes.
got they got it to work reliably, and so now it's a matter of, I guess, because you need millions of those, or
Right.
many of them in a typical quantum computer, and so there's the usual things of how do you pack them all together, because you don't want to taking up a whole room, right? It still has to be
Correct.
densely packed. So, but I was impressed with the way he characterized some of the problems that you can solve with quantum computing. I mean, he basically said you can solve world hunger with quantum
Yeah,
computing,
that was cool.
and then reverse global warming. I mean, because some of these problems are so hard that they would take traditional computers years to figure out, right? How to do, what's the correct algorithm or the correct distribution method for food, or the right amount of carbons to be sucked out of the atmosphere. I thought that was you know and
Yeah,
that
but you
should
didn't talk about the Frankenstein monster aspect of it. Supposedly, all encryption techniques that we have are out the window as soon
Yeah,
as
with
quantum is
quantum.
real.
Yeah.
And in this
I
world, with humanity being what it is,
I was thinking about that, Mark, when he talked about this thing, and I mean, and I've done a little bit of QShop programming,
Mhm.
so I have a little bit of insights into it, and it's mostly about calculus, right? I mean, QShop is mostly a calculus calculator or a
Okay.
solver, uh,
Hmm.
and at least so from my perspective, I don't know if I mean I don't know enough of the algorithms that I used in TLS and all that, but I don't think that you know it will solve those kind of problems. Maybe it can be bent to solve those kind of problems, but I don't think it directly solves those problems. It solves physical problems, right? Problems that we come across in the physical world are able to be solved in a quantum computer. So you're
I
you're
thought the
trying to
point of it
I,
though was that it's able to do math with all values at one time.
Yeah, I would say it's the calculation capabilities, right? This now we're gonna get into cool TLS
But
stuff,
it's
but like TLS is all about none of the TLS algorithms are unsolvable from a math perspective. It just
Right.
takes
Too
so
long.
much time to solve that it's not worth the effort for any one connection or
Right.
or packet that's encrypted. If you make the computing power sufficiently faster, again, the implementation is certainly up for
yeah,
debate.
yeah, yeah.
But if you make it sufficiently fast, now those aren't hard problems
Right.
anymore. That's
It's a
my
massive-
understanding of.
Yeah, the analogy for me is that it's a really massively parallel way to
Yeah.
attack a math problem, which
Yeah.
seems like that would just tear. Because you're right, if you iterate through a decryption, then that takes to crack it. That takes a long time, even with the scale we can bring to it. But my understanding is that quantum will break all that down. And
Yeah.
then we'll have to figure out a different way, maybe using quantum to actually encrypt things safely.
That's right.
Yeah.
Or we
Great.
could learn to trust each other. Oh, right. Never mind.
Yeah. We're back to quantum there. Yeah. We'll go back there.
Right, Mark, any kind of last closing thoughts as we wind up here?
No, like I said, it was just like, for me, it was a shot in the arm of, that how good we are at innovation. And so I think with my new role, this CSA developer advocate role that I'm in addition to trying to change how people do traditional things, I want to start to, get people enthusiastic about what's coming. Not selling the roadmap, that's a different conversation, and then start to get people more in the mode of being able to change how they do things. Again, from the DevOps handbook, I was fascinated because I think it was Etsy that was quoted as they have evolved their architecture 5 times in whatever the life of the company is. You won't find an enterprise that's pulled that off. Their normal way is they get pushed to the wall and then start over. And so I think there's a lot of stuff, and the fact that that we have done all of this stuff and bringing our skills to it and our innovation is very exciting to me still.
Great.
Awesome.
Well, thanks for coming back, Mark. Always good to see you.
Hey, my pleasure.
Thank you.
As always.
Thanks, folks.